So if we just look back again, right, just like what we have looked at earlier on, 2's complement of -3. Alright, we know that like over here it's actually being expressed as 8 bits. Alright, I'm just going to like show you again of how we get this -3 being expressed in terms of its 2's complement. Alright, so first step is what? Always take the positive value of it, right? The positive value. So let's take this as the first step. So first step for positive value of 3, we know that it's actually 1 1. Alright, but over here, since this is 8 bits, alright, so you have 0 here, you have 0 here. Alright, so you add another 4 0. 1 2 3 4. Alright, so these are 8 bits. Second step is what? Second step is inverting every single bit. Alright, so this becomes 1 1 1 1 1 1 0 0. This is the second step on inverting the bit. Alright, last step is, do you remember, it's actually additional of adding 1 at the rightmost bit. Alright, so in the end this will give us 1 1 1 1. Alright, then 1 1 0 1. Alright, when we add this up, these two up, this is what I get here. Alright, so what happens is that in here it's 10. 10 is represented, if the number is positive, it's represented the same way. Negative, you do the 3 steps that I've shown you earlier, and then you add those up together. Okay, so one thing for 2's complement is that if you have an extra bit, alright, because now you start with 8 bits, right? So sometimes when you have everything added together, you have extra bit on the leftmost side. What do you do to it? You discard it. Alright, so that's all about it. 2's complement is very simple. Everything maintains the same for the positive number. If negative number, then express it first step, express in positive form, invert all the bits, and then add 1. Alright, anything to do with extra bits on the left hand side, alright, just discard it at the end. Okay, so that's about it for 2's complement. So for addition, this is about multiplication and all that, the same way as how you multiply your normal number. Okay, so I'm not gonna go through with you. The same as binary division, you see here. So this is 0, then what do you get? Alright, and then but this is a rather simplified version already, so you always can give it a try on how this can be. Alright, this is 1 11, so this is where your 11 comes from, and then what happens, alright, you do your binary subtraction and what you get after, and so on. Alright, and to just play safe, every time you can check your final answer with the decimal equivalent. Yeah, so 2's complement, well, I think this is whatever that's summarizing what that we have talked about. Alright, an indication though, if you have the most significant bit, this literally means the leftmost bit. Alright, if it's a 0, basically it means that our number is positive. If it's a 1, it literally means that the number is negative. How so? I think I can show it to you in the previous slide, like you see over here. Alright, so if this is a 10, this is a positive number. You look at the left hand side. Alright, the leftmost is actually 0 over here. But if it's a negative number, the leftmost is actually represented as 1. So that's one of the way of how you know that a number is actually positive or negative. Okay, that's what it means over here. Okay, so This is just the final answer of or just a summary of how it actually is. Okay, represent as positive number, invert it, and add 1. If you have any carry out, which means any additional bit on the left hand side, you just ignore it or discard it. Alright, so do give it a try. This is example of how it would be for positive number, negative number. So give it a try on your own. The solution is already there. I think I would not have to go through this with you, but rather based on the example that I've shown, I think it's important that you can give it a try on your own. Alright, same steps as usual, and just the same. This is when you want to take from this binary number, you want to change to decimal number. So what do? The same way, alright, because you do know that, look at it here, remember the leftmost bit or the most significant bit, they call it you see that it's 1, so you know that the number is actually negative. Alright, so what you do is you basically just do back just reverse the process and all. Alright, and you know that for the fact that since it starts with 1, therefore your final answer, because over here you get it as 12, right, but the final answer, you know that is actually negative, all because you know that the 1 here, the MSB here, 1 actually represents a negative. Alright, hope you are very clear with it. So this is another example. Express 19 and negative 11 as 8-bit 2's complement. So worry not about what you think sometimes if you are in doubt, like, oh, how many bits should I be expressing and all that. So always remember to read the question properly. The questions usually will indicate how many bits they require. Alright, so follow the number of bits that they require so that you don't go off track of whatever answer that you're not supposed to get. Alright, so same way of how you get it. So hexadecimal addition and all that is just the same. Okay, you know that, for example, D, A, B, C, D, so this is actually 13. Alright, so 13 plus 8, you get 21, right? You know why we get 5 here? Because this is hexadecimal. So 21, if we put a carry of 1 over here, right, the carry of 1 actually indicates 16. Okay, so that's why we get 5 here. Remember, 13 plus 8, I get 21. 21, I put 5 here because when I put a carry of 1 here, a carry of 1 for a hexadecimal number, it literally means 16. That's why this is 5. Alright, because this is actually 21. So 5, this is 1. Alright, so 1, 7, 1, this is 9. And then same goes 5, 9, this is actually 14, right? 14 is literally being expressed as E, so no issue with that. But F is 15, and then A is 10, so 25, right? So for 25, you have 1 carry bit here, which is 16. So 25 minus 16 gives you actually 9. So that's how you gauge what to put here, because you always have to remember, every time that you put a carry 1, it literally means that it's actually 16. Alright, but once you have put the carry, like for example here, you have put 1, right? And then you need to add this up together. When you add this up, you just add it as 1 as usual. But always just remember, when you do the carry and all that, just when you decide on what you put over here, you always remember that every 1 actually represents a 16 because it is the base. Alright, I think for hexadecimal addition it requires a little bit of practice, because you need to sort of like convert and reconvert what literally is and not, and for the carry bit and things like that. Alright, so you have seen this example. Do always give it a try on your own for it, yeah? So same goes for subtraction as well, alright? Every time you have a borrow and things like that, it's also indicating it comes from 16.